This video will take a look at the quotient rule. So let's start with saying we have two functions, f and g, and we want to take the derivative of the quotient of f of x over g of x. So it's important here to pay attention to which one's on top. So when I go to take the derivative, I get g of x times f prime of x minus f of x times g prime of x over g of x squared. So pay attention here that order really is important because of the negative sign that we have in the quotient rule. So we're always looking at which one am I taking the derivative of and which one comes first. So it wouldn't matter if you had said let's do the derivative of f times g, or if you say g times f prime of x. Either one is fine, but it's important that you do these two first before you subtract doing f times g prime. So pay attention to order. This can be a little tricky, and it takes a little while to memorize. So I have another way that you could say it. So quotient rule alternative. And here when I'm looking at f and g, instead of calling them f and g, I'm going to call them high, low. So high is the one in the numerator, low is the one in the denominator. So I just do it by placement. And totally, I did not make this up. I learned this when I took calculus, and so it's how I think of it when I do it in my head. So here I have the derivative of high over low is low d high minus high d low over low low. All right, so what does that mean? D stands for derivative. So I'm going to do low, which is the bottom, d high, derivative of the top, minus high, back to the top, d low, derivative of the bottom. Low low is the bottom squared, but low low just sounds cooler. So I say low low instead of low squared. And again, that's how I learned it. So it sounds a little like a yodel, low d high minus high d low over low low, but I don't care. As long as you remember it, it doesn't matter if it sounds crazy or not. So don't worry about that. Just worry about, can you remember it, and will you understand when we're talking about it? All right, so we need to do some examples. So we're going to start with this one, natural log of x over x, and I think it's a pretty easy one to start with. So notice I'm starting with low, which is x. I'm going to take the derivative of the natural log of x, then minus high, ln of x, d low, derivative of x, and then low low is x squared. All right, so let's clean that up. So the x is good. I'm going to leave it alone. Derivative of ln is 1 over x, so you'll see that's right here. And then I leave ln of x alone. Derivative of x is 1. So I've done the derivative part. Now I just want to simplify. X times 1 over x just simplifies to 1. Ln of x times 1 is simply ln of x. And notice the denominator. I'm not touching it. I leave it alone. You're not going to see us expand it at any time. It's always just going to be like, hey, it's down there. We'll take a look at it, and I'll have some examples where it will say, oh, could we make it any better? But usually just think that low low is just going to hang out and just keep carrying down from one step to the other. So my final answer here is 1 minus the natural log of x divided by x squared. Okay, so let's try another example. This time I have 2x plus 3 divided by 5x plus 6. So once again, I'm going to do the setup. So I'm going to start low, 5x plus 6, and then do d high. So I'm going to take the derivative of 2x plus 3, then minus, go back to high, 2x plus 3, and then d low, so derivative of 5x plus 6 over low low, 5x plus 6 squared. All right, so let's see what we can do to make that better. So the things that don't have derivative signs, like the 5x plus 6, I'm just going to rewrite it. But 2x plus 3, the derivative, is just this 2, so I write it down. 2x plus 3, bring it on down. 5x plus 6, I'm taking the derivative, I have a 5. So let's multiply that out. 2 times 5x is 10x, 2 times 6 is 12. And then here, because of this minus, when I distribute the 5, I'm going to think about it as being a negative 5. So I can get two things done at once. I can distribute the negative, I can distribute the 5, and I won't mess anything up. So I'm going to do negative 5 times 2x is negative 10x. Negative 5 times 3 is negative 15. Well, this works out kind of pretty. You can see I have a 10x and I have a 10x, so those two things are going to cancel out. And if you want to, we could just go ahead and cancel them. So let's say get rid of that. Get rid of that. And then I have 12 minus 15, which gives me negative 3. So my final answer is negative 3 over 5x plus 6 squared. And again, notice I just kept bringing that low low down with me from every step. I didn't touch it. I didn't simplify it. I didn't think about it at all. Okay. So let's change it up. Let's bring e into our quotient. So this one says 6x cubed minus 4 divided by e to the x. All right, so again, start low. So e to the x, d high, 6x cubed minus 4. Take that derivative, and then minus high, 6x cubed minus 4, and then d low, derivative of e to the x, and then low on the bottom. All right, so go back through. E to the x, just bring it down. 6x cubed becomes 18x squared. The 4 goes away. Keep that minus sign. Keep the 6x cubed minus 4. Derivative of e to the x, remember that's the easy one. It's e to the x again. All right, so look at this. I have e to the x on the left, I have e to the x on the right, and I have e to the x squared on the bottom. So when I look, everywhere has an e to the x. Because it's everywhere, I can get rid of one of them. I can get rid of e, and then e. So what I mean by get rid of one is I'm factoring that e to the x out, canceling it with 1 in the denominator, but I really kind of think of it as a 1, 2, 3. It has to be in the left, it has to be in the right for me to be able to cancel one of them in the bottom. So if it was just on this side, I can't cancel. If it's just on this side, can't cancel. It has to be left, right, bottom. So it has to be one from every term if I'm going to cancel. Canceling is nice because then it becomes smaller. So you can see I kept my 18x squared. I'm going to drop these parentheses, which is going to push this negative through. So I'm going to have minus 6x cubed, but this negative will become positive 4, and that 1 e to the x now is left on the bottom. So we did do something with the denominator in this case, but we didn't expand it. We just canceled where we could. And we'll just keep learning throughout our discussions as when can we do it, when can we not. It'll be important to pay attention to. All right, so let's have a different look. This one says f of x is 1 over x squared plus 4x plus 5. So I want to give you this different look of, well, the denominator is interesting, but the numerator is just 1. So what happens with that? So we're still going to start low. So I have my x squared plus 4x plus 5, and then I'll have the derivative of 1. That's d high. And then minus high, the 1. D low, derivative of x squared plus 4x plus 5, and then this low on the bottom. Okay, so this parenthesis just comes straight down. We're not doing anything to it. Remember, derivative of a constant is 0. So this derivative of 1 is 0. Keep this 1. X squared plus 4x plus 5, just the power rule, 2x plus 4. Okay, so multiplying by 0 says I'm really wiping this out. This one's just going to go away, and I have this negative 1 times 2x plus 4. Don't lose the negative when you cancel that out. Think I need to distribute that negative through, so I have 2x minus 4. So I have negative 2x minus 4. Let me make sure I say the right thing. So I have negative 2x, negative 4, and then that low just stayed the same on this one. All right, so here's one that's a little ugly. It's the last one we're going to do in this video. But again, you can see every one of the examples I gave, I just added a little twist to it. So I threw an ln, I threw an e, just do a constant. So this one you can see the trick. The new thing I'm doing is I threw in a radical. So I have this square root of x. Okay. Even though we're really focusing on the quotient rule here, as part of this quotient rule, we will have to do the power rule. That's pretty normal. So I want to change that square root of x over to a power. So the power it is 1/2. So I have 4x to the 1/2. So this 4x to the 1/2 is on top. X plus 1 is on the bottom. And we're going to start doing the derivative. So I have my low, x plus 1. And then I already went ahead and did d high because I don't want you to think we're always going to write out every single step. That'll get too long. Right now we're just learning the rules. And then later we're going to even make this bigger. So we do want to start kind of cutting steps a little. So this is the first one where I cut a step. So I did low and I immediately jumped to d high. So you can see I did 1/2 times 4 is 2. Here's my x again. My new exponent, because I subtracted 1, is negative 1/2. So there's my low d high, and then minus high, so 4x to the 1/2. D low, well, I'm taking the derivative of x plus 1, it's 1. And then I have the low again, x plus 1 squared. Okay, so next step I did is I took any of these exponents, and I just said, well, what does that mean? Let's relook at that. So the negative 1/2 is the square root of x. The positive 1/2 is the square root of x. So the negative, I put the square root of x in the denominator. The positive, I put it right beside the number. All right, this is kind of a mess because I have this fraction here, 2 over the square root of x, within this bigger fraction that I have. So I'm going to try to clean that up, and in this case I decided, well, why don't we do a common denominator? Okay, so this part is fine. I have a square root of x. So what I want to do is give the right side a square root of x as well. So I'm going to multiply by the square root of x over the square root of x. That way I get the square root of x in the bottom. Okay. So on the first term, I'm just going to multiply 2 times x plus 1. You can see I have 2x plus 2, square root of x, because that's what I had before. And over here, the square root of x times the square root of x gives me x. So my numerator is 4x, and the denominator is square root of x, because that's what I wanted. Notice I'm just dragging this x plus 1 squared along. All right, now I can combine these terms. So when I do that, I had 2x, but I subtract 4x. So 2x minus 4x is negative 2x. And then I sum my plus 2 over the square root of x, and then x plus 1 squared. This being in the denominator, this is a denominator. Those two belong together, so I'm just going to drop that square root of x down there with it. And now I have negative 2x plus 2 all over the square root of x times x plus 1 squared. It may not look simple, it may not look pretty, but it is the derivative, and this is the form I would want it in when we finish. All right, so that's the end of our video, and I hope that helps out, and I'll try to make some later for the other rules.